There's the first volume. Whew. Cool. They're at the front. If you weren't here Friday, you didn't get a book. Come up to the front and get a pink book and a blue book out of that box. The blue book is your work. The pink book is your notes. Wait a sec. What was pink?
Plasma pink.
Plasma pink. And what was blue? Terrestrial teal, yes?
Or blast-off blue.
Blast-off blue. I don't remember which they were. The girls of the class informed me that they were terrestrial teal. So this would be, I believe, in your books, page 20. '22. You were supposed to do the volumes of pages 22 to 25, I believe. Now, I know for a fact that many of you didn't do this. That's okay. So you are writing them down now. But you don't get to complain when we come time to test day that you don't know what you're doing because you didn't practice. So there's the first volume. And remember, all volumes of all pyramids and prisms are area of the base times the height for a prism. And for a pyramid, it's area of the base times the height divided by 3. So the first one is 7,680. The second one is 33,280. And you got it by doing 32 times 48 times 65. Area of the base, 32 by 48, times the height of 65, but then divided by 3 because it's a pyramid. The cone was 1,650 pi. And some of you will have gone one step further than that, which is fine. You will have gone on your calculator 1,650 times the pi button and gotten an answer of around 5,000. $5,183.63 if you went one step further, which you are allowed to do. And the cone was 500 pi. If you went one step further than that, it was 1,570.8. Or the cylinder, yes, sorry. Everyone all right with those? Did I ask you to do the volumes of this worksheet? I asked you to do that as well, yes? Okay. Those volumes are highlighted in yellow. If you need me to discuss any of them, I can. Everyone is okay with the first two? Once again, if you didn't get them done, you will want to either watch the video tonight and find the right answers, or if you don't care, don't. 144. Now this one is a little bit tricky. This guy right here, because most people your age do this. They draw that line, and they find this volume, and then they find this volume, and then they add them together. And that's okay. However, you also could have done this. This entire shape, which is my favorite Tetris piece, by the way, that whole shape has a surface area, yes? And is repeated going back 4 times. So if you found this surface area, which was 12 by 4 plus 4 by 4, and then multiplied that by 4, you would still get the volume. Understand? Because this shape that's shaded in red repeats that many times. So this red shape becomes my base area. even though it's not on the bottom, because that is the shape that repeats. Does everybody understand that? Do you have to do this that way? No, of course not. You can do this any way you want. But that's just another way you could do it that is less work, I think, than finding volume, volume, and adding them together. Okay? But the answer, whichever way you did it, was 256. Next one. That is the volume there, 90. That is the volume there. This one, again, you could have found this whole area and multiplied it by 15. If you found the area of just the front. Because that shape, this shape, repeats all the way to the back. Does everybody understand that? I call it the base area, not because it's the bottom, but because it's the shape that the whole prism is based upon. Good? Okay. So 90 and 420. I don't care about the units right now. Right? Numbers are more important. This one, the volume was 396. And on this one, I found that again by finding this area, just that part, and multiplying it by 6. Because that shape repeats 6 times going backwards. You could also have found this volume and then this volume and added them together. I don't care. And this guy was 72. If you went one step further, he was 72. He was 226.19. And you didn't have to do the paint question because you would never tell me the volume of a room. You would never fill a room with paint. Everybody good with volume of regular shaped things? Excellent. Let's move on then. Your next thing in your book should be spheres. And that should be the bottom of page 28 for you guys right now. So we are on page 28. You should have a bunch of white space at the bottom of page 28. Yeah? Pink book. Blue book is work. Pink book is notes. Pink book, page 28. I hope. What?
We have 51 enough and our pages aren't numbered.
Oh, right. That weird thing happened at 51. Yeah. Okay. So you're looking for the page about spheres, which will be right around the last piece of notes you did. I got to fix that for next year. Get the page numbers better. Okay, so up until now, every three-dimensional shape we've dealt with has been based on another shape, right? If you fold 4 triangles together, you get a pyramid. If you fold a rectangle with 2 circles, you get a cylinder, right? Spheres aren't like that. Spheres are a circle spun in 3 dimensions an infinite amount of times around a center point. So there is no way to draw it flat. Do you understand what I'm saying? We can draw a cylinder flat, we can draw a pyramid flat, we can draw a prism flat. We cannot draw a sphere flat. It doesn't exist. So that's out the window right away. So the question becomes, how then did we get these formulas? Because, of course, you guys are smart kids. Yes? You know how we figured out surface area formulas and volume formulas from folding them all up. right? There's 4 triangles. Okay, so it's 4 times base times height divided by 2, 2, right? But these don't work that way. These were found just like pi was found through experimentation. Okay? So basically what they did was took squares and a circle, cut the square into even pieces, and worked out how much the circle filled up. That was how we first got pi. We didn't call it pi. They didn't call it pi, but they figured out, I'm not worried about it. They did this math in grade 2. They're allowed to sleep. That's how we found pi. They do the same thing for this. Okay? Same thing for volume. In volume, they used empty space. So what they did was they took, you guys all know the story, the guy jumped in the bathtub goes up, he goes eureka and figures out how that the crown is pure gold. That story. That's how they figured out volume. They had a volume that they knew, compared it to a sphere that was almost the same, and then worked out the math. That's all you need to know. More importantly, you need to know how to use it. Now, as a regular sphere, these are really easy. You just plug in just like you would normally, okay? The only thing I will remind you of is this. I don't like writing this way. I like to write this as 4 pi r cubed, all divided by 3. Because most of you guys don't like dealing with a fraction like that. I like to write it that way. Everybody cool? It's real easy. You just fill in the formula the way you see it. Where it gets problematic and why you have blank space at the bottom of that page is for hemispheres. What does the word hemisphere mean in English? We live in the northern one of it. What is a hemisphere? It's half a sphere. Hemispheres are half spheres. Now, there's a problem with this. Because as soon as I say something is half, what do you do automatically? Pardon? You divide by 2, right? I have $20. I'm going to give you half that. How much you get? $10. Easy peasy, right? So, if the surface area of a sphere equals 4 pi r squared, right? Then what's a hemisphere?
No, it's not.
It should be that divided by 2, shouldn't it? It isn't, is it? It should be that, though, shouldn't it? Which would get me 2 pi r squared, correct? That's what you want it to be, but it isn't, is it? Because when you make a hemisphere and you do this, I cut off the top of it, yes? That's now half a sphere, yes? What did that make right here? More surface area. And what shape is that? It's a circle, right? So, yes, this part out here is 4 pi r squared divided by 2, but I just made this circle here, didn't I? What is the formula for area of a circle? 1 pi r squared, right? So I got to add pi r squared. So the surface area of a hemisphere is really 2 pi r squareds plus 1 pi r squared, which is 3 pi r squareds. Everyone understand? That is for a solid hemisphere. Now the question becomes, what if it's a hollow hemisphere? What's the surface area? It's still 4 pi r squared, isn't it? Because when you cut that sphere in half, all that surface area from the top is now inside. Everybody understand? Okay. That is surface area. Surface area of a hemisphere. Cool? All right. Now, of course, we also have to do volume of a hemisphere. So volume of a sphere is 4 pi r cubed divided by 3. Now, you guys are smart kids. If I cut a sphere in half, is there any volume being added? No, of course not. It's just gone, isn't it? So I don't have to worry about adding anything, but I do have to cut this in half, don't I? And that's hideous. That's fraction divided by fraction. Barf. But what is that really? That's 4 pi r cubed over 2. Nice 2, moron. 3, times 1/2. Because times 1/2 is the same as divide by 2, isn't it? So the volume of a hemisphere, 4 pi r cubed times 1 is 4 pi r cubed over what? You guys know how to multiply fractions. It's over 6. So these two formulas don't show up anywhere on your formula sheet because you got to figure them out. I help you out by discussing it and letting you see what they are. Does everybody understand? Okay. What's the key I'm adding, or the key part of this? When you are doing surface area of solid figures, if you cut them in half, you are increasing that surface area. Understand? It's not just divided by 2. When you're doing volume, it is just divided by 2. Got it? Everyone cool? Okay. Let's carry on then. Today's class is not about math as much as it is about calculator work. Okay? We're going to spend a bit of time today making sure that we can make our calculators do what we want them to do. All right? So, let's start with this. Now, please remember, you guys, most of the time I try to give you real life questions in these units that apply to real life. Yes? Sometimes I have to give you stupid math class questions. This is one of those times. Amber's going to wrap a basketball as a present for her brother. First of all, she would never wrap a basketball, would she? Because if you got a basketball wrapped as a ball, it would be pretty obvious what it was. You would either put it in a box or you would deflate it and roll it up. Because if you gave me a round present, oh, thanks, a basketball. There's not a lot of surprise there. So she would never wrap it this way. But we're going to go about it anyway. And also, what kind of a loser knows how much wrapping paper before you actually wrap it? Right? You guys, you're smart kids. When you wrap a present, you get the box, you drop it on the wrapping paper, you roll it over a couple times, and you cut off a little extra and you wrap it, right? And you're always left over with a little, right? Then you just fold that under and tape it. Right? That's not how I wrap presents. I don't like waste. So I try and get it perfectly. And then I'm always left with a little bit of the present that's never covered. So then I cut a little strip off another piece of wrapping paper and tape it on. Then my wife gets mad at me. She's like, why don't you just wrap it properly? Because I don't want to waste it. You're such an idiot. What are you going to do? My wife cares about wrapping things more than I do. They're just going to tear it off. So, first of all, what is my problem here? Am I looking for volume or surface area when I'm wrapping something up? Surface area, of course. So I have the surface area of a sphere equals 4 pi r squared. Yeah? What do I know in this question? I know the surface area. I need the R. So where can I write a number in this question? On the left. 2,500 equals 4 pi r squared. I need r, correct? So I got to do algebra. Now I'm going to remind you guys, if I asked you for 3x plus 7 equals 16, could you solve that? Of course you could, right? You could do that in your sleep. You do minus 7 from both sides, 3x equals 9, divide by 3, x equals 3, right? Because in algebra, you do the opposite of what you see. So, what do I need to do here to find the radius? I need to divide by 4. That will take care of the 4. What else must I divide by? Pi, to take care of the pi. If I do that to this side, what do I have to do over here? Same thing. So I've divided by 4 pi. So now I have 2,500 over 4 pi equals r squared. What gets rid of r squared? Square root, just like at the end of Pythagoras, right? So I do square root to both sides, and r equals the square root of 2,500 over 4 pi. Now, I need everybody to stop for a minute. Don't touch your calculators. Don't think about nothing. Just wait a second. The concept for this question ends here. Do you understand what I am saying? If you get to here, I am happy. But this is not an answer, is it? Does everybody understand what I'm saying? You can't do this in your head, though, can you? So when you can't do math in your head, in math class, where do you go? To your calculator. Now, that is difficult to punch into your calculator. Okay? So what I'm going to do right now is I'm going to shut up and let everybody go to town with their calculator and tell me what the answer for R is. And I'm going to get a bunch of different numbers. And some of those numbers, most of those numbers will be wrong. I will be surprised if I get somebody that gets this answer right. Okay? You can talk to your neighbor. This isn't a test. Try to tell me what the radius of this basketball is. Go. And after you've tried, I'm going to ask you how you found it. If you don't have a calculator, and obviously you cannot do this exercise. And it gives me a chance to remind you, go get a calculator. You cannot do this course without a calculator. You need one, so go get one. No. You had 44.2, L? Okay. 5.3? 5.3. Just keep saying numbers. 14.1. 28.2. Anybody else got another number for me? I got a 44.3. Anybody else? You also got 3.9? Okay. All right. 7.9? 7.9. All right. Let's stop for a second. Radius is half the diameter, yes? So let's look at these answers. 28 means half the basketball is that wide, meaning the whole basketball is that big. Is that how big a basketball is? No. So 28 has to be wrong. 44. Well, that is 44. So that's half the basketball. So the whole basketball is That's 74. Add 14 more centimeters to that. So is 44 correct? No. 5.3. That is 5. Which means the whole basketball is that big. Is that right? No. 14.1. That's 14. So the whole basketball is about that big. Is that right? Of all the ones you've seen, that is the only one that it could possibly be, isn't it? Because 4, 3 is that, doubled is that. No basketball is that big, is it? So let me ask you this. All of you did very simple math, isn't it? Like, let's think about this. That's asking you to divide two things and then get the square root of the answer. That shouldn't have been that difficult, should it? I gave you your calculators. And your calculator told you all these answers. But you have to use your brain, don't you? Because only one of those is correct, and it is 14.1. And I believe it was Jacob that got it. So the question becomes not, can you do the math? Because where is the math here? Is the math at that step, or is the math on your calculator? Where are you doing math? No, L. Your calculator is not doing math. You're doing the math, and you are telling your calculator what to do. All right? So this class is not calculator 10, but you need to know how to use your calculators. Right? So let's break this down a little bit. What am I asking you to do here? I'm asking for you to tell me the square root of what? Of 2,500 divided by 4 times pi, correct? How are we going to punch this into our calculator? It's very difficult to do in one step. Almost none of you are probably able to do it in one step. But let's talk about how to do it. The first thing I need to do, if I asked you to tell me the square root of 4, what would you use? 2. You wouldn't even go to your calculator, would you? It's 2, right? What if I wanted the square root of 8 divided by 2? It's still 2. Why is it, Sean? 8 divided by 2 is still 4, so that's still the square root of 4, isn't it? Right? What if I asked you for the square root of 256 divided by 64? Yeah, you would do this under here and then square root the answer, wouldn't you? So, does that change what we do here? I have to find what this is before I can square root, can't I? Don't I? So how do I do 2,500 divided by 4 pi on my calculator? Here is where most of you made your mistake. What happens on your calculator? What is happening here? How would I enter that into my machine? What would you type? Don't worry if you did it wrong. That's the whole point. You would push 2,500, then the divided by button, then 4, and then times pi, correct? Now, let's think about this for a sec. Your calculator does not know what you want it to do, does it, Adam? No, your calculator has no idea what you want it to. Your calculator does what you tell it to do, yes? Your calculator, however, follows all math rules, doesn't it? What's the number one math rule when there's more than one operation? BEDMAS. So your calculator knows BEDMAS. What's your calculator going to do there? It's going to do 2,500 divided by 4, which is 625, and then it's going to multiply by pi. Is that what you want? No. You want 2,500 divided by 4 pi. So what do you have to do to your calculator to keep 4 and pi together, Jacob, you must use brackets. You guys have to get good with the brackets on your calculator. So what you really need to do here is 2,500 divided by bracket 4. Now, some of you need to push 4 times pi, and some of you can just push 4 pi. It depends on your calculator. You have to know what your calculator will let you do. So I'm going to put the times, because even if you don't have to, if you put it, it will still work. Times pi, close brackets, equals. And if you do these, you will get vastly different answers. This is the one we want, though. Does everybody understand that? Everyone cool? So everybody grab your calculator. And you can see I was doing this in another class. 2,500 divided by 4 times pi gets me 1,963. That's not the right answer. What I need is 2,500 divided by bracket 4 pi. Now, my calculator knows to do brackets first and divide 2,500 by all of that. Does everybody understand? Then when I hit enter, I get the correct answer. Everybody cool with that? Again, this is not calculator 10, but you do need to know how to use your calculators. Everybody good? Now, Jacob. Yeah, that works too. That works too. So everybody okay with what I've done here? Now I need to get a square root of that. Now I'm going to introduce you, and I've already talked about it, but I'm going to spend some time with it right now. A very powerful key on your calculator that you are going to use a lot of in the next 2 years. You can see on my calculator right here. Some of you will be able to see it, some of you won't. That says ANS. That is short for answer. When I push that button, my calculator will automatically give me whatever the last thing I pushed equals for. Some of you will have a button on your calculator that says ANS. Some of you will have it like mine, where I have to go second function ANS. But use it, because it remembers what you last did. So watch what I can do. I don't need to write this down. Now, my calculator holds a bunch of stuff on its screen, yes? But some of you can't do this, right? But your calculator remembers the last thing you did. So watch what I can do now. I can go square root of answer. The last thing, my last answer is now going to get square rooted. And there's my 14.1. Is everybody cool with that? You need to be able to use your machines. Because the number one problem you guys have with math isn't this side of things. You guys will set it up perfectly. Then you go to your calculator, you punch it in, and you'll get the totally wrong answer. And on a multiple choice test, the thing that's on your calculator is not there, is it? Or it's the wrong answer. And then you think that you can't do math. Do you see the problem here? It is not that you cannot do math. It is that you do not know how to work your calculator. Everybody get it? For example, a great many of you are going to learn how to drive. You're probably going to learn how to drive on an automatic. You know how to drive. But if you hop in my car, that is a standard, are you going anywhere? Not for a while, even though you know how to drive. You just don't know how to operate that particular machine. Understand? You have to know how your calculator works. Now, you can go one step further with this. You could punch this whole equation into your calculator in one shot. You can punch this whole thing in one shot when you get really, really good. Okay? It just needs an extra set of brackets. But you don't need to be there yet. Do you understand what I'm saying? L. Mm-hmm. But then you still got to put brackets around the 4 pi. So you did 2,500 divided by bracket. No. You did the square root of 2,500. Then you hit the A, B, C button. Then you had bracket 4 pi. So you had ABC 4, and then you did bracket pi. That's what you did. But then your calculator did 2,500 divided by 4, which is 625, and then multiplied it by pi. And 625 by pi is 1900. The square root of 1900 is 44. Okay? If you wanted to do it your way, you needed to do this. Bracket at the front, and you probably could have gotten away with just one bracket at the end. That might have worked. But I don't want to spend a lot of time on this because everybody's got different machines, right? Then you need to put a bracket, double set of brackets. That will work. Everybody cool? All right, let's go on to the next question. Now, the point of this is how much math did I do before I touched my calculator in this question? All of it, didn't I? I used my calculator for the very, very last step, right? So when do you think we should go to our calculator on question 2? At the very, very end again. Because your calculator doesn't know a thing. So let's read this question. Jim places 3 golf balls into a cardboard box. The balls fit snugly against the sides of the box. I want to know how much of the box is empty space. Now you may be saying to yourself, Myers, that's a math class question. Don't give me any of that crap. That is not a real life question. Actually, it kind of is. There are people that are paid a lot of money to decide how to package things. Because packaging costs money. And every time you buy something in the store that has a package on it, you're paying for that package. Because the guys that manufactured whatever you just bought paid somebody for that package. So the less packaging, they try to tell you that less packaging is so they can be kind to the environment. It's not true. It's so they can save money. That's the only reason anybody does things in business. But it is actually a real life question. So, how are we going to figure this out? I don't want you to go to your calculator until you've figured it out. So let's think for a minute. What do I know? Well, I've got 3 spheres and a rectangular prism, yes? And I want to know the wasted space. So what math am I going to do to find out how much empty space there is? Pardon? You need volume. So I know I'm going to need volumes of spheres and volumes of prisms, yes? And what math is going to tell me the difference in those volumes? There's only 4 kinds of math. What is the one that's going to tell me the difference? Subtraction. Which is bigger, the box or the golf balls? The box. So this must be volume of the box minus the volume of the golf balls, yes? Okay. What's the volume of the box? 3 times 3 times 9. 3 times 3 times 9. Right? What about the golf balls? You do know. What's the volume of a golf ball? What's the volume of one sphere, Adam? 4 pi r cubed over 3, yes? Right? And how many of them are there? 3. So I must need to subtract 3, 4 pi r cubed over 3, correct? I'm not going to my calculator yet because this is really ugly. Wait a minute, Emily. Of course you can cancel the 2 3s. So what I really have is 3 times 3 times 9, which I can do in my head, can't I? What is 3 times 3? And what's 9 times 9? So I have 81 minus, now here we have trouble. The 3's are gone, so it's 4 pi r. What's r? Radius. What's the radius? Yes, you know. It's not 13.5. Oh, yeah, it is. I see what you did. Yes. The radius is 1.5, isn't it? Because the ball fits in the box, yes? The box is 3 centimeters. So what's half of that? 1.5 cubed. Got it? Now, we haven't touched our calculator yet, have we? This is the math. Now, to punch that into your calculator, you've got some trouble now. A great many of you probably won't be able to get that in one shot. Everybody go to your calculator now, because there's nothing there that you don't know how to do from the 9th grade, and tell me what you think the answer is going to be. You can take as many steps as you want. So, I'll let you guys have a couple more seconds, then I will ask for your answers to that question. There is no rush. Yeet, what do you have? 38.61. Okay. Anybody got something different? You got 62.1? 62.15. Anybody got something else? Anybody got something else? Again, the whole point of this is this. If you are here, if you understand how we got to there, I'm very, very happy. Because how to find the actual answers just comes from practicing with your calculator. So what would you type in here? What is happening here? That's 81 minus that times that cubed. So according to BEDMAS, I got to keep something in line, don't I? If I don't punch this in order, if I'm bad with my calculator, where do I need to start? At 81 or this here? I got to start over here, don't I? If I'm not going to do it all in one try. And where do I start over here? Do I start with the 4 times pi or the 1.5 cubed? 1.5 cubed, because exponents before multiply, right? So to do this, I need to find this part out first. Who remembers how to do exponents on their calculator? It's tough because every calculator is different. You're either looking for the XY button or the YX button or the mountain, which is called a caret. Or some of you have, the newest calculators I've seen have an X with a little blank. You got to find one of those. Whatever your calculator has is the one you're going to use. I have the little mountain button right there. See it? So if I'm doing this step by step, I need to do 1.5 exponent button 3 times pi times 4, then hit equals. Then that's going to be an answer, isn't it? Whatever that answer is. Then I need to go 81 minus my ANS key and equals. And you will get the right answer. And the right answer is 38.58. So Yeet was very close. It's 38.5. Actually, it's 38.59 because it's 38.5888. Now, can you punch this in properly, all in one shot? Yes, because your calculator knows bed mass. Your calculator will do it right. I could punch this all at one go. 81 minus, then you don't need any brackets. 4 pi times 1.5 exponent button 3 equals. And you'll get the right answer that way too. I don't care what you do. Okay? Pardon, Sean? As long as you show me what you're thinking. Because chances are, Sean, what if somebody did all of this and then punched in their calculator and told me the answer was 62? I got to give you something, because up to here, you've been perfect, right? And is this class called Calculator 10? No, it's called Math 10. So I got to be able to give you some credit for knowing what you're doing. I don't want to say this kid can't do math because this kid punches stuff into the calculator wrong, right? But too many of you guys don't show me this. You only show me this. What is my only option? If you hand me in a blank sheet with that number written right here. And what's that? Nothing, because that's not the right answer. You picking up what I'm putting down? And I know I'm looking at you. That's just because we're having this talk. It's not because I think you're going to do that, right? But there are kids in this room that are going to hand me blank sheets with an answer. But I did it all on my calculator. Yeah, but it's wrong. Well, I should get something. For what? The only thing you did was punch stuff into your calculator, which you did wrongly. So I'm giving you what you should get, which is nothing. You picking up what I'm putting down? That is why us math teachers despise the question. Do I need to show work? Go ahead and don't, but you better make sure you have all the right answers. Good? Now, the smarter members of this room will recognize that you didn't learn anything new today, did you? Math-wise, did we do anything new? Just the hemisphere stuff. But even that wasn't new, right? All we did today was discuss how to make our calculators work. I want for you guys, the next thing in your books should be worksheet 1-6. Is that the case? It should start with cones, pyramids, and spheres. So you're going to do that page up to, and you are going to stop. You're going to stop at the page that says problems and applications. That is where you stop. Don't do that page. Don't do that. That's where you stop. It would be page 30, 31, 32, and 33 if you had your page numbers. Everybody cool? Some of them ask for surface area. Some of them ask for volume. Some of them ask for both. Some of them give you questions that you have a formula for. Some of them you have to actually figure the formula out. Everybody cool? Go.